Welcome, friends. This is the answers explaining session for task 8. Before explaining the answers for task 8 questions, I will explain the answer for today's question. Okay, this is our first question. First of all, I will read and explain you the question. Okay, a mild steel tank of wall thickness 12 mm contains a water at 100 degrees Celsius. The atmospheric temperature is 20 degrees Celsius. The thermal conductivity of mild steel is 50 watt per meter Kelvin, and the heat transfer coefficient for inside and outside the tank are 2850 and 10 watt per meter square Kelvin respectively. Calculate the rate of heat loss per meter square of tank surface and the temperature of the outside surface of the tank. Okay, we have to find the heat loss per meter square and outside surface temperature of the tank. I have solved this question. I will show you the answer now. Okay, now you can see the answer in the screen. First of all, given data from the question. Okay, the thickness is 12 mm and water's inside temperature is 100 degrees Celsius and atmospheric temperature is 20 degrees Celsius. Here the thermal conductivity of mild steel is 50 watt per meter Kelvin and heat transfer coefficient is 2850 watt per meter square. It is inside, and for outside the heat transfer coefficient is 1 by, it's not a 1 by 10, it's actually wrong. It is 10 watt per meter square Kelvin. Okay, you change it. Okay, here we have to find the heat loss per meter square. Therefore the area will be in this question will be taken as 1 meter square. Okay, that's why I had written here as 1 meter square. Okay, to find, you know that outside surface temperature, okay, outside wall in temperature, or it's just a walls outside temperature, outside surface temperature. Okay, we know the general formula that heat loss Q is equal to change in temperature by resistance and temperature difference del T, we take it as for volt. Therefore T1 minus T3. Okay, or just you take it as T1 minus Ta, which is the atmospheric temperature. That is what the atmosphere temperature is taken as T3 here. Okay, first here the water to wall is heat is transferring through the convection mode, then through the wall through conduction mode, then from wall to outside atmosphere through convection. So here therefore two convection process and one conduction process, therefore the resistance for the three process is written below. Okay, just substituting the values, we will get the directly Q value as 795.2 watt per meter square. We have found out that heat loss per meter square. Okay, is it enough for this question? Because we have found out the heat transfer rate, so the answer containing option is only option D. Okay, we no need to find the outside surface temperature by wasting time. Okay, but I have so showed you how to calculate it too. Okay, here, we know that for a steady state condition heat transfer rate will be constant, so Q is equal to, I am considering only conduction. Okay, okay, substituting all others except we didn't know that T2, which is the surface temperature. Okay, from this we can calculate the T2 as 99.552 degrees Celsius. Therefore the correct answer for this option for this question is option D. Okay, okay, this is the first question of task 8, which is from general aptitude section. Okay, first of all I will read the question. It was estimated that 52 men can complete a strip in a newly constructed highway connecting the cities P and Q in 10 days. Due to an emergency, 12 men were sent to another project. How many number of days more than the original estimate will be required to complete the strip? Okay, in this question we no need of any workout calculation. We can solve it by mind by a simple logic. Okay, here you read the question that how many number of days more than the original is. Okay, therefore we need not to find the total days, we have to find the more than days, that is additional days to complete this work. Okay, by 40 minutes, because 12 men were leaved, so there will be a 40 men only. Okay, here there are four options. You look at the options, four options. Okay, you can definitely eliminate the option B and C, because they have told us to find that more than, that is additional days, therefore it will be in a reduced manner. It will be in, we can, once reading the question itself we can understand that it will be in less than 10. Okay, so therefore the answers will be A or D. Okay, we have to find that. Okay, the logic here is 52 men can complete a strip in 10 days. Okay, one day's work is how much means? Okay, just divide it by 10 days. Okay, that is 52 by 10, we will get the 5.2 means, that is one day there will be a requirement of 5.2 months. Okay, 2 months works, therefore 12 men were leaved, so 5.10 how much times it will, that is 5.2, how much time it will gives the 2, that is more than 2 times, therefore the answer will be 3 days only. Okay, it will definitely not be 5 days. Okay, because there will be a more difference. Oh, so you can choose here option A is the answer. Okay, that is 3 days. First of all, this is the second question. Okay, which is from our topic heat and mass transfer. I am feeling bad, that is I am so sorry that in yesterday's task 8 video this question is too small to read, so I think no one can't able to read the question. Okay, you can read the question now. Okay, and you try itself, then you see the answer which is explained by me. Okay, I'm so sorry. Okay, this is the second question I will read now. Okay, in a furnace the inner and outer surface, outer sides of the brick wall are maintained at a 100, that is 1100 degrees Celsius and 700 degrees Celsius respectively, and the conductivity of the wall is 2.5 watt per meter Kelvin. The brick wall is covered by an insulating material of thermal conductivity K2. The thickness of the insulation is 1 by 4th of the thickness of the brick wall. Therefore, the outer surface of the insulation is 200 degrees Celsius. Therefore, the heat flux through the composite wall is 2500 watt per meter square. Okay, the value of K2, we have to find the value of K2, that is round off to 1 decimal place. The K2 means the insulation conductivity we have to find. I have solved this question, I will explain you now. Okay, okay, this is the answer which is solved by me. Okay, we know that thermal conductivity for brick is 2.5 watt per meter Kelvin, and that is given Q flux, that is heat flux rate is 2500 watt per meter square, and respective temperatures are given. We have to find the insulation materials conductivity. Okay, here also the heat transfer rate will be constant, because it is also one of the steady state temperature. Okay, steady state condition. So I am using the formula Q dot is equal to conduction 1 plus conduction 2, that is both the conduction for brick materials heat transfer rate and the insulation material heat transfer rate will be constant here. So I am equating and substituting the values, and in place of L1 I am substituting that 4 times of L2, because they have given the ratio. Okay, and in this we can cancel L2 L2, then finally we will unknown in this equation is K2. If you find the K2, the answer will be 0.5 watt per meter curve. That's it today's session. Okay, and subscribe my channel and click the bell icon to receive the daily questions daily. Okay, thank you.